Hi guys, let's look at the next question in our chapter, Midpoint Theorem and its converse. Before we start, let's quickly revise what is the midpoint theorem. Midpoint theorem states that in case you have a triangle and if you join the midpoint of any two sides, then this line segment is parallel to the third side and is half of it, which means if this side is of length x, then this length is x by 2, half of it. That's basically what the midpoint theorem states. And the converse of this would be if one midpoint is given and the line is given parallel, which means this point is the midpoint of the third side. Perfect. So this is basically what the midpoint theorem states. Now let's look at our next question. The next question says in trapezium ABCD, AB is parallel to CD. So AB and parallel are given CD. P is midpoint of AD. So P is midpoint. Now we already know that this is from the chapter midpoint theorem, but as soon as you see the midpoint word being used, try looking for triangles. Right, so I can see the small triangle, but there is no name given. Yeah, there is a name given. This is Q. Sorry, my mistake. This is Q. So I can look at this triangle, but there are no midpoints of this. So let's look at this big triangle ABD. Is this midpoint? Yes, and this line is parallel. So then I can think that this is applying midpoint theorem somehow. So let's go back to the question. P is midpoint of AD and PR is parallel to AB. We need to prove that PR is equal to half of AB plus CD. So let's look at this triangle ADB that we just identified. So let's look at this triangle ADB. So in triangle ADB, number one, P is midpoint of AD. Why? This is given. And number two would be PQ is parallel to AB. Why? Since PR parallel to AB. This is given. Yes, PR is parallel to AB. This is given. So now one midpoint is given and the line is given parallel, which means we are looking at converse. So using converse of midpoint theorem, what do I get? What I get is Q is midpoint of DB. What it basically means is DQ is equal to BQ. So this is one thing that I learned from the converse of midpoint theorem. And number four I get is PQ is equal to half of AB. These are the two things that I get from using the converse of midpoint theorem. Perfect. Now I've got AB, this one triangle. Let's look at this second triangle now. The second triangle that we'll refer to would be BCD. Perfect. Now let's look at this triangle. In this we've already said that Q is midpoint of BD, which means these two sides are equal, and QR is parallel to DC, already given, which means we can again apply midpoint theorem. So now let's look at this. So in triangle BCD, number 5, Q is midpoint of BD. Where did we get this from? From number 3. And number 6 would be QR is parallel to DC, since PR parallel to DC. This is given. So again using converse of midpoint theorem. So converse of midpoint theorem, what I get is number 7, which is R is midpoint of BC, and number 8 would be QR is equal to half CD. So I need to calculate PR, right? So PR, okay, so PR, this is my number 9. PR is equal to PQ plus QR, which is equal to half of AB plus half of CD, right? Why? Since PQ is equal to half AB from number 4 and QR is equal to half CD. This is from number 8. So this is void number 10. Let's look at number 11. PR will be equal to anything common here. Yes, half is common, so I take this out. This becomes half of AB plus CD. Is this what they wanted me to prove? Yes, PR is equal to half of AB plus CD, hence proved. Perfect. So again, I will repeat, as soon as you see, notice one midpoint or line of parallel lines, try looking for triangles. So here I found two triangles, ABD. I applied midpoint theorem here first, and then I applied it in this triangle BCD, and I was able to get my answer. Perfect. Let's move on to the next question. The next question that we solve would be question number 6. So question number 6 says the diagonals of quadrilateral intersect at right angle. So what kind of a quadrilateral? Not given. The diagonals intersect at right angle. So we already know properties of certain quadrilaterals. We only know that only two types of quadrilaterals are where the diagonals intersect at right angle, but we will not talk about that right. So now let's look at this. Diagonals intersect at right angle. Prove that the figure obtained by joining the midpoint of the adjacent side of the quadrilateral is a rectangle. Oh, so then let's call this A, B, C, and D. What is given is that the diagonals intersect at right angle. So these are the two diagonals. What is given is that this is 90 degree. Let's give this point name O. And what we need to prove that the figure obtained by joining the midpoint of the adjacent side. So if this is adjacent side and this is the midpoint, then we need to join these midpoints. So let's join them. Let's join this. Let's join these two midpoints. Let's join this midpoint, and let's join this midpoint. Perfect. Let's give them some names. This is E, F, G, and H. So what is given is that the AC and BD are perpendicular to each other, and what we need to prove that the quadrilateral is a right angle. So what we have to prove? So to prove that E, F, G, H is a rectangle. So how can we prove it to be a rectangle? If we prove opposite sides are equal and parallel, and if I prove that the vertex angles are all 90 degree. So this is what I need to prove. Again, like I said the previous time, as soon as you see midpoint, you should be looking at triangles and try and prove something equal. Okay? So what is given is, let's mark that this and this are equal, AE and BE are equal, BF and CF are equal, CG and DG are equal. Right? These are three lines, 1, 2, or this is 4 lines here. Right? They are not. Okay. So these two sides are equal, these two sides are equal, these two sides are equal. Perfect. This is what is given. So let's start writing something. So let's look at first triangle that I look at, which will be like the previous time. I look at the triangle being formed by the diagonal AC. So let's look at what we can get. In triangle ADC, number 1 would be H and G are midpoints. Right? So using midpoint theorem, what do I get? I get HG is parallel to AC, and number 3 I get is HG is equal to half AC. Yes, so HG is parallel to AC and HG is equal to half AC. Now let's look at the second triangle which AC makes. The second triangle that AC makes would be ACB. So let's look at this triangle. In triangle ABC, number 4 is E and F are midpoints. This is given. So using midpoint theorem, what do I get? Number 5 I get is EF is parallel to AC, and number 6 I get is EF is equal to half AC. So this question is similar to the one that we did earlier, but there it was given to be a rectangle, so we knew that the two diagonals are equal. Here the two diagonals are not given equal. So let's see what I've got. I've got these three. I've been able to prove that HG and EF are parallel, and I have also got that this is half of AC, this is also half of AC, which means HG and EF are equal. So let's write from 2 and 5 I get HG is parallel to EF. This is my point number 7, and from 3 and 6 I get number 8, which is HG is equal to EF. So HG and EF are equal, which means one pair of opposite sides is parallel and equal, which means this definitely will make a parallelogram. Now let's look at any other triangle. Yes, the next triangle that I refer to would be triangle made by the diagonal BD. So let's look at this. So in triangle BCD, number 9 would be G and F are midpoints. So what does it give us? Using midpoint theorem, what I get is number 10, GF parallel to BD, and number 11, GF is equal to half of BD. We'll do exactly the same thing which the last triangle, which is triangle ABD. Let's look at this now. So in triangle ABD, number 12 would be H and E are midpoints. So using midpoint theorem, number 13 I get is HE is parallel to BD, and number 14, HE is equal to half of BD. So like we did for the first one, we will also get the same thing, which means HE is equal to GF. Let's write this down using parallel, which is 10 and 13. I get number 15, which is HE is parallel to GF, and using 11 and 14 I get number 16, which is HE is equal to GF. So I have proven that both pair of opposite sides are equal, but we still need to prove that the vertex angles are 90. So let's see what we can get. So I've got this line parallel to this line, and I've got GE parallel to HE. What does it make? Let's give some more vertex angle names. So let's call this GH. So we've already at H. So let's call this vertex I. Let's call this vertex J. Let's call this vertex K. And let's call this vertex L. So now I've got I, J, K, and L. So this angle is 90. If this line, which is BD and GF, are parallel, what does it make angle J here and angle O? Yes, these are co-interior angles, which means the sum of these would be 180, which means this angle will have to be 90, right? So I've got this angle as 90. Now if AC is parallel to EF, what does it make angle J and angle F? Yes, these are corresponding angles, which means this angle and this angle will be 90. Similarly, if GF is parallel to HE, what does it make angle F and angle E? Yes, they will be co-interior angles, which means the sum of them should be 180. So if this is 90, this will have to be 90. Similarly, EF parallel to HG, if this angle is 90, this will also have to be 90 because this will be co-interior angle. And then in quadrilateral EFGH, if three angles are 90, well, the fourth angle will be 90 because the sum of all four angles will be 360. So now let's start writing this down. So angle KOJ, this is my number 17. is equal to angle, not equal to, plus angle OJG is equal to 180 degree. Why? Sum of O interior angle. Therefore, angle OJG is equal to 180 degree minus 90 degree is equal to 90 degree. So I have got my angle OJG, which is this angle, as 90. So now once I get one angle as 90, let me try and prove angle F as 90. So let's start writing this now. Number 19 would be angle OJG is equal to angle EFG is equal to 90 degree. Why? These are corresponding angles are equal. Done. So we've got one vertex angle as 90. Let's look at the next one. So next one would be number 20, which is angle EFG plus angle FEH is equal to 180 degree. This is sum of co-interior angle, which means number 21 would be angle FEH is equal to 180 degree minus 90 degree is equal to 90 degree. So now I've got angle E also as 90 degree. Done. Let's try and prove angle H as 90 degree now. So let's look at number 22, which would be angle FEH plus angle EHG is equal to 180 degree. This is sum of co-interior angle is 180 degree. I hope you realize these questions are slightly long, but the same concept being applied again and again and again. So that brings me to point number 23. Therefore, angle EHG is equal to 180 degree minus 90 degree is equal to 90 degree. So now I've got this angle also as 90 degree. So in quadrilateral EFGH, 90 degree plus 90 degree plus 90 degree plus angle FGH is equal to 360 degree. Why? This is angle sum property. Sum of four angles in a quadrilateral is always 360 degree. Therefore, angle FGH is equal to 360 degree minus 270 degree is equal to 90 degree. So we've got angle FGH is equal to 90 degree. So we've been able to prove that all four vertex angles are 90, and we've been able to prove that both pair of opposite sides are equal. So let's write this down. Since vertex angles are 90 degree and EF is equal to HG and EH is equal to FG, therefore quadrilateral EFGH is a rectangle. Both pair of opposite sides are equal and the vertex angles are 90 degree. Thank you so much. Long question. I'll give you some time to reflect on it, do it on your own. I'll see you with the next video. Bye bye. Take care. Be safe.